It's midday over the continent of North America. The sun is shining. But wait, what's that? Do you see that large black spot moving over the continent? What could it be? What could have caused such a phenomenon? To find out, let's take a look at the bigger picture. This is our solar system, our neighborhood in space. At the center of the solar system is our sun, making up more than 99% of the mass, or stuff, in the solar system. Orbiting the sun are all the planets, moons, dwarf planets, asteroids, and comets that make up the remaining 1% of the mass of our solar system. As each object in the solar system follows its orbital path, we move closer and closer on our countdown to one of the great celestial events that happens in our solar system. This also just so happens to be a spectacular cosmic coincidence. To get a better understanding of what we're waiting for on this countdown, let's take a closer look at our sun. Our sun is so large that you could fit more than 1 million Earths inside it. While our sun may be large compared to the Earth, it is an average-sized star compared to other stars in the galaxy. The sun is approximately 93 million miles away from the Earth. This distance is commonly referred to as 1 astronomical unit. It is this distance that makes the sun appear much larger to us in the sky than other stars. And here's Earth, our home, third planet from the sun. The Earth is the only planet in the solar system with 1 moon. That's one part in the great cosmic coincidence we are a part of. The moon takes 29.5 days to revolve around the Earth. As it does, it rotates in such a way that the same side of the moon is always facing the Earth. This phenomenon is known as tidal locking. The moon orbits the Earth from approximately 250,000 miles away. Its diameter is a quarter that of Earth's, and you could fit 49 moons inside the Earth. Despite its small size, its relative closeness compared to that of the sun means that for us on Earth, the moon appears to be about the same size as the sun in the sky. We've now returned to Earth, and we have traveled in time to August 21st, 2017. On this day, which will start out as any other, something special is about to happen. Remember that black spot that swept across the country? Any idea about what it could be? Well, it involves a dance that the sun, Earth, and moon are continually performing. You see, the Earth is in constant motion revolving around the sun. It makes 1 revolution around the sun every 365 days, or 1 year. The moon is also in constant motion as it revolves around the Earth. It takes the moon approximately 29 days to make 1 revolution around the Earth. Every so often, these orbital paths line up to create an eclipse. An eclipse is just a shadow being cast on an object. If you imagine the sun as a giant flashlight, when the moon passes between the Earth and the sun, it creates a shadow. When this happens, we call it a solar eclipse. If you were to witness a solar eclipse on the Earth, the sky would become dark, and it would look like something was blocking the sun. So the question is, if eclipses are caused by the shadows of the Earth or the moon, and it takes the moon about 1 month to revolve around the Earth, why aren't there eclipses every month? The answer has to do with the tilt of the moon's orbit around the Earth. You see, the orbit of the moon has a tilt of approximately 5 degrees in relation to the Earth's orbit around the sun. And so, sometimes the moon passes either above or below the Earth and won't cast a shadow. It is only when the moon's orbit is in just the right spot that it will cast a shadow on the Earth. This also explains why some eclipses are known as partial eclipses and others are total eclipses. A partial eclipse occurs when the moon's shadow is not centered on the Earth. The last partial solar eclipse was visible in the United States on October 23, 2014. Now, when the sun, earth, and moon align in just the right way, something special happens. It is called a total eclipse. This occurs when orbits of all three are in just the right spot that the sun and moon have the same apparent size from the earth, and the orbit of the moon is just right that it casts its entire shadow on the earth. The last time a total solar eclipse has been viewed from the mainland United States was in 1918, and the next total solar eclipse to be visible in the U.S. will occur on August 21st, 2017, just a few months from now. This total eclipse is special because it will take place across the entire country, beginning in the Pacific Northwest coast and moving across to the East Coast. Since this eclipse spans the entire continental United States, it is being referred to as the Great American Eclipse. While viewers in the DFW Metroplex will be treated to a partial eclipse, many major cities in Kansas, Missouri, and Tennessee are within the path of totality and are within a day's drive to visit. So, what will you experience if you decide to make a trip to view a total solar eclipse? First, and most important, you must always remember to never look directly at the sun without proper viewing devices from your local planetarium or astronomer. Looking directly at the sun can cause severe damage to your eyes that may be irreversible. Fortunately, with proper tools, it is possible to safely view the solar eclipse. From beginning to end, the process of an eclipse lasts nearly 3 hours, and it occurs in phases. The first phase is known as first contact, and it marks the start of the countdown to totality. This is when the disk of the moon first begins to move in front of the sun. As this phase continues over the course of about an hour, it will look as if something is taking a bite out of the sun. The sun will appear to have a crescent shape, and it will still be bright outside. At 10 to 15 minutes before totality, you will start to see a change to the quality of daylight. Minute by minute, the sky will begin to dim and shadows will grow sharper. You may also experience a temperature drop. If there are birds or other wildlife in your location, they may noticeably respond to the coming eclipse with sounds and chirps. At 1 to 2 minutes before totality, your senses may start to come alive with anticipation. You may notice that the sky looks much different than you're used to seeing. Not quite day and not quite night. If you look to the ground, you may see shadow bands that flicker and dance. They look similar to sunlight at the bottom of a swimming pool. In the seconds before totality, you may see a thin crescent of the sun suddenly change to a thin string of beads. This is known as Bailey's beads. They occur as the last of the sunlight passes through the valleys and mountains of the moon. And totality! As the last of the light of the sun disappears behind the moon, you realize you are standing completely in the moon's shadow. At this point, it is safe to remove your solar viewing glasses and enjoy the breathtaking view of this cosmic coincidence. This phase lasts approximately 2 minutes, so make the best of it. The sky will be suddenly dark, as if it is the middle of the night, only you'll know it's the middle of the day. Brighter stars and planets such as Venus and Mercury will be visible during this time. If you bring binoculars, you may also be able to view what look like licks of flame known as solar prominences coming from the sun. Or you may just want to enjoy the light show in the sky as the eclipse continues. After the approximately 2 minutes of totality, the show is not over. There is still a third act. Everything that occurred leading up to totality will happen again, just in reverse until more and more of the sun is revealed. If you missed any phenomena such as Bailey's beads or shadow bands, This is a second chance to view them. Eventually, the sky will begin to brighten as the disk of the moon moves out of the path of the sun. This final phase will last approximately 1 hour. As the moon recedes out of the path of the sun, take time to appreciate how for a moment in time you had the chance to be present for one of the greatest cosmic shows around, a total solar eclipse.